Kinetic friction. We know about what is friction, and whenever some of the forces, whenever the one body is stays on another body, the force between the two bodies, the surfaces, the force which acts if the body is trying to move or moving, some of the opposite forces acting between the two surfaces is considered as a physics, that force. That frictional force is three types. We know that is static friction, or it is considered as whenever it is maximum is called limiting friction, and as well as when the body is sliding over a body or rolling a body, that can be considered as a kinetic or a dynamic friction. In earlier video we discussed about static friction and what is the laws of static friction, and as well as the coefficient of static friction and what the friction will depend, static friction depends on. Now the second one, the types of friction, the second one is kinetic friction, or it also called as a dynamic friction. Means here when a body is sliding over another body or any surface, then the force acts between the two surfaces which is opposite direction to the motion of a body is called a kinetic or a dynamic friction. Means the resistance encountered by a body, whatever the body is traveling, the resistance encountered by a body, a sliding body on the surface. Means whenever surface is offering some resistance that is encountered, that body is encountered by a sliding body, so that the body can be in motion. So that the resistance is called as a friction, that is kinetic friction. Whenever the body is sliding over another on the surface, that resistance encountered by a body, sliding body on a surface, on the surface. For example, if the body is moving in this direction, this is the surface and the mass of a body, and whenever the force is acting in this direction, so that the body is sliding on the surface in this direction, then some of the force offered, opposite force offered, resistance offered by a surface on the body which is sliding over the surface, then the frictional force when the body is moving, the force which is acting tangentially between the two surfaces, means the motion of a body which opposite by the surface, that frictional force is called as a kinetic friction. Means when the two bodies is having that, whenever the body is moving in this direction, the force resistance, means the resistance opposite force which is offered by a surface is called as a kinetic frictional force. So that the resistance encountered by a sliding body, this body is encountering, means opposing or overcoming the force which is offered by a surface, that is by a sliding body on the surface, the surface offering that is kinetic friction when the body is sliding on the surface, also called as the force of friction. The force of friction when a body is in state of motion over the surface. When the body is over the surface, the body is sliding or is in motion, then the force is offered by the surface is called a frictional force, that is a kinetic friction. We can say that whenever the body is in motion, then friction offered by the surface is called as a kinetic friction. So that then what are the laws of kinetic friction? One base of what are the laws kinetic friction will act. Earlier we discussed about the static friction. In case, for example, if we want to throw some of the bike or some of the body, at the starting body stays at rest, we need extra force too, we need more force to move that body. Means the static friction is acting which is equal to the applied force on the body. So that if we encountered that frictional force offered by the surface, if we overcoming that, we encountering that frictional force offered by the surface by applying the external force, net external force on your body, at the starting stage we need to use more force to move that body. After the body, whenever it slides for this while, slides for a distance, then that much of force doesn't needed when the body is in motion. So that here we can say that the kinetic friction, whenever the body is in motion, the frictional force which is offered by the surface is less than when the body stays in a static condition. So that we can say that is a kinetic friction is always acts as a static friction acts, the kinetic friction is also always acts in the direction of opposite to the direction of the motion of a body. Means Fk means kinetic friction is always acts in a direction opposite to the direction in which the body is moving. Means here the body is moving in this direction. It's a body, mass of a body is moving in this direction. We know that normal is acting perpendicular, and mass due to the gravitational force, that is weight acting downwards, and the force body is moving in this direction. When the body is moving in this direction, the kinetic friction is acting in opposite direction always, which is opposes the motion of a body. We know that whenever we riding a bicycle, if we stop the riding bicycle, the bicycle will move some of the distance and stops at that place, because of the surface is offered the resistance on the wheel tire, so that the vehicle will move for some distance, then it will stop. So like that, if we put the brake, then after some of the distance, means whenever put the brake, due to the frictional force between the both of the tire and the surface, the vehicle will be stops. Means some of the frictional force is acting between the two surfaces. When the body is in motion, we can hear that one. So that the kinetic friction is always in a direction opposite to the direction in which the body is moving. So next one is the kinetic friction is independent of area of contact as well as the static friction is also same. Here the kinetic friction is independent of area of contact. When the body is sliding on the surface, if the more surface area is also in contact, also the kinetic friction will remain same, and the less frictional force is also moving, the less area of contact is also with the surface, also same amount of frictional force is acting on that body. So that here the kinetic friction is independent of area of contact, it doesn't depend on the area of contact. So that means here the body is the total area of contact also moving in this direction, the same amount of force we can use to move this body, and as well as when the body is less area of contact also moving, whenever it is less area of contact with this one, then also same amount of frictional force, if the force is utilized by the external agency, then the same amount of force which is used to move this body. So like that, it is independent of kinetic friction or dynamic friction is independent of area of contact, but for the it is depends on the here also, it depends for small velocities the kinetic friction is independent. For small velocities the kinetic friction is independent of velocities for small velocities. If in case of for a given surface, given velocity between the not too large, not too small, for a given surfaces, when the normal reaction is constant, then stays at constant, so that we can say that the for a velocity which is given velocity between the two surfaces, which is certified verified velocity, given sum of the velocity not too small, not too larger, then kinetic friction is independent of its velocity. If the velocity is too large, then the velocity of sliding is very large, then we can say that the heat is generated between the surfaces. And so thermal welding, the sort of thermal welding may create, so that the frictional force will be increases enormously. When the velocity is too large, the heat will be developed. They may create that the thermal welding between the two surfaces, so that here we can say that the kinetic friction will be increases enormously whenever, if the body is moving like this, then very fast, then between the two surfaces some of the heat will be generated, so that the friction force may be increases enormously. So this is about loss of kinetic friction. And one more thing is the kinetic friction. We know that the kinetic friction as well as static friction is also directly proportional to the normal reaction. Kinetic friction is also directly proportional to the normal reaction, so that Fk is proportional to N. From that equation we can get that the proportionality constant mu k that is Fk is equal to mu Kn, or mu K is equal to Fk by N, means Fk means kinetic friction, N means normal reaction, and this mu K is a proportionality constant, so that the mu K is proportionality constant is called a coefficient of kinetic friction, so that the mu K means a kind of coefficient of kinetic friction. What is meant by the coefficient of kinetic friction? Here the ratio of the kinetic friction to the normal reaction is called a coefficient of kinetic friction, means the ratio of kinetic friction to normal reaction is called a coefficient of kinetic friction. So that here we discussed about that the kinetic friction means whenever the body is in rest, the body stays at rest, we need more force to overcome the resistance offered by the surface, means whenever the body is in static condition we require more, then the external force is required more to move that body. Once that body is moved further, then we don't require that much amount of force to slide the body on the surface. So that we can say that the resistance offered by the body is more in static condition, less means the static friction is more than the kinetic friction. So that here the mu K value is less than the mu S for a given pair of surface. That means to say here the static friction is greater than the kinetic friction, means Fs is greater than the Fk. So that we know that Fs is equal to mu Sn is greater than mu Kn. From the equations we know that, from the coefficient of friction formula, from the laws of friction, from that we can get that mu S is greater than mu K. That means to say the coefficient of kinetic friction is less than the coefficient of static friction. Means when the body when the stays at rest, the surface offered the resistance is more, means the static friction is more than the when the body is moving, the sliding friction is less. Sorry, the kinetic friction is less. So here we can say that the coefficient of kinetic friction is less than the static friction. So that mu K is less than mu S. Mu K means the coefficient of kinetic friction, mu S be the coefficient of static friction. So that here about the kinetic friction. Once again, kinetic friction means here the resistance encountered by a sliding body on the surface. Always body experiences the opposite force by the surfaces where the body is sliding over. So that the resistance depends on the frictional force between the two surfaces depends on the body. So that here static friction also we discussed about that the static friction depends on the molecular nature of the material and the relative smoothness between the two surfaces, as well as here about the kinetic friction. Here we know that from the definition, the force of friction when a body is in state of motion over the surface, what the body is stays rest, another body is in motion, means the surface staying at rest and then the body is moving, then we can say that that body offered some of the external force on the surface to overcome the frictional force or opposing force. That opposing force is a frictional force. The frictional force offered by the surface is overcoming by the net external force. So that we can say that the Fk is always opposite direction, means kinetic friction or static friction is always acts in opposite direction to the direction of the external force which is acting. If the external force is more, that body will move, otherwise that body will stay at rest. But the frictional force and the frictional force of static frictional force or kinetic frictional force which is always acting in opposite direction to the direction of motion of a body or direction of the net external force acting on that body. So that the force is acting in this direction, the remaining frictional force acting in opposite direction, and it is independent of area of contact. If in case of the area is more, the same amount of external force is to move the body, and if the less area of contact is there between this, then also the same amount of frictional force, the same amount of external force which is required to move the body. So that here we can say that the area means we know that normal reaction acting perpendicularly, and the weight of the mass due to gravitational force will acting mg in this direction. The surface is same, so that here the total weight is acting in this direction. Then for a small velocities, the kinetic friction is independent of for small velocities for a given velocity, not too small and not too large. So if in case of the too large velocities, for too large velocities the kinetic friction will be increases enormously due to the large velocity. Some of the heat produced may create that thermal welding between the two surfaces, so that the kinetic friction will increases enormously. We know that the kinetic friction is directly proportional to the normal reaction. From that equation we can get that the proportionality constant called as a coefficient of friction. From the coefficient of friction we know that the ratio of kinetic friction to the normal reaction, so that the mu k is equal to Fk by N be the formula for a coefficient of kinetic friction. Here kinetic friction is less than the static friction, so that the kinetic friction is less than the static friction. From that equation we can get that the coefficient of kinetic friction is also less than the coefficient of static friction. That means to say when the body is staying at rest, means in the static condition we should use an external force more than the kinetic when the body is in motion. So this is about kinetic friction. And one more is in kinetic friction is this means to say this is a sliding friction. Whenever the body is sliding over the another body is called in kinetic friction. There is two types of there. The one is the kind of sliding friction and another one is a rolling friction. So sliding friction means when the body is sliding over another body. When the body is sliding over another body. In case of rolling friction means the body is rolling like this. The chalks is rolling from my hand. That is a rolling friction which is offered by the whenever it is a body is rolling. So that here the small difference between the sliding and rolling will be this: when the body is moving, the area of contact is there. In this area, the area of contact, the body at a point of contact, the particles will be in motion. The body is in motion, the area is in motion. It will possess velocity. In case of a sliding body, in case of a rolling body, that particles having zero velocity means for example, if the body is rolling over this, then this particle is having a zero velocity because of another particle comes to this place, so that this body doesn't have any velocity. This particle, this area doesn't have any velocity. Whenever it is sliding like this, then another particle comes to play, and this particle is also having zero velocity come with at the area of point of contact, at the point of contact. So that this is the difference between the sliding and the rolling friction. Now we are going to know about the rolling friction. So rolling friction, here we know that the resistance encountered by a rolling body on a surface means here the rolling body, if the body is in static condition, if this is mass of a body and this body will Fs will acting in this direction, means the static friction will acting in this direction, and as well as if that body is in motion, if that body is in motion means F is acting in this direction, then kinetic friction is also acting in this direction. But it is both are independent of area of contact. Static friction and sliding friction both are kinetic friction in this case, the both are independent of area of contact. But we know that the rolling friction means that is denoted with F suffix R, so that the resistance encountered by a rolling body is rolling on the surface, the resistance offered by the surface encountered by the rolling body, which is less, very very less than the sliding friction or whatever dynamic friction and also static friction. We know that if the body is sliding, we can experience in this case, for example, if we are moving the cylinder at our home, if the cylinder is in static condition, we require more energy to move that. Otherwise, if the cylinder is moved further, whenever we use the external force, that body will move, cylinder moves. That much of force we don't need whenever the body is in motion. Otherwise, if the cylinder is on the floor, we are rolling that cylinder, then we require less amount of external force to roll that cylinder. Because of here we can say that the static friction is more than the kinetic friction, and as well as the kinetic friction is more than the rolling friction. Here that the Fr depends on area of contact. It depends on area of contact. If the area of contact is more, area of contact is increases, then frictional force is also increases. So that's why the frictional force depends on the frictional force, means the rolling frictional force depends on the area of contact. Nowadays we know that to get the Apollo tires are using for the cars. Apollo type of tires which is used, and also that filled with the less air for the cars. Because of to increase the area of contact between the surface to the tire is rolling on the surface road. So that here whenever the area of contact is less, then the frictional force between the tire to the surface will be less. So that whenever the velocity is more, then that body can be slide up, that body can be slipped. But if in case the area of contact is more, then due to this one, the rolling friction depends on the area of contact. Because of each and every part, the area friction will be applied on the area. So that here we don't require any frictional external force to change. Only if we increase the area of contact, then rolling friction can be increases. There is the first law of rolling friction, means the rolling friction depends on the area of contact. Nowadays in every cars we can see that in the tires the less amount of air is filling, because of to increase the area of contact whenever the car is moving very fast, then due to the area of contact is more, the car doesn't slip. So that's why here the Fr depends on the area of contact, means the rolling friction depends on the area of contact. If the area of contact increases, the frictional force increases. Whenever if we put the brake on that, then we know that if in case for a small example, for example we are riding a bicycle, if the air fully filled on the tire, we can go easily with a less amount of external force. But if the air is less on the tires, the contact force between the tires and the road is more. We need more energy, we need more force to use to move the body. So that here the Fr depends on area of contact. And we know that rolling friction is inversely proportional to its radius. Means if the radius is more, here is also if the radius is more. This is the best example. If the radius is more, the less frictional force, the less rolling frictional force. If the radius is less, in this case the radius is less, so that's why we can say that the rolling friction is more. So that the rolling friction is inversely proportional to radius. Once again, if the tire is like this, if the body is like this, with the area of contact is the radius is more. If the area of contact is less, if the radius is less, then here this is radius is more and this radius is less. So that's why we can say that Fr is inversely proportional to the radius. Fr is inversely proportional to the radius of the rolling body. If in case of Rm is more, then we can say that radius is more, the rolling friction is less, then radius is less, then frictional force rolling friction is more, because of the area of contact will be increases whenever the radius decreases. So that here we can say that the rolling friction is inversely proportional to the radius. Then the Fr is directly proportional to the normal reaction. We know that how much the normal reaction is acts and same amount of frictional force acting on the body. Then from that equation we can get that Fr is proportional to N, Fr is equal to mu R N, mu R is equal to Fr by N. Means that is the rolling friction is directly proportional to the normal reaction. By removing the proportionality we can get the proportionality constant mu R into normal reaction. From this equation mu R is equal to, whenever we get the normal reaction this side, then we can get that it becomes denominator, that mu R is equal to Fr by N, Fr by N. So that the mu R means that is called as proportionality constant, is called as a coefficient of rolling friction, coefficient of rolling friction. So that from the coefficient of rolling friction we know that the ratio of rolling friction to normal reaction, that is the equation for that mu R is equal to Fr by N. So here we can say that when a body is moving on a surface, when a body is moving on a surface, the rolling friction is less. From that equation by conclusion we can write that if the body is staying at rest, then static friction more, means when the bike or another thing is whenever bike is in rest condition, if we want to move the bike, then we require more force, external force from the static to change its static condition to the kinetic condition, dynamic condition. So that Fs is more than the kinetic friction, means the frictional force offered by the surface at the body is in static condition is more than whenever the body is sliding on the surface. In case if the body is in motion, means it is dragging, means sliding on that, it is sliding, then Fk is acting on that body. We know that if in case of sliding is moving, means sliding rolling on the body, means like motion of the body is like this, then also rolling friction which is offered by this also on opposite direction, but at the time of the point of contact the particle's velocity is 0. The particle at the point of contact, in a rolling friction, velocity of that area is 0. Velocity of that area 0, because of another point, another area comes to play, and whenever it is moving another area comes to play, and another area comes to play whenever the body is rolling. This is sliding, this is in static condition, and this is rolling, so that at the point of contact the area of that body velocity will be 0, so that the frictional force will be less. Because of point of contact is less, then frictional force is also less than the kinetic friction is more than the rolling friction. We can conclude from this. From this also we can write that coefficient of static friction is greater than coefficient of kinetic friction and more greater than coefficient of a rolling friction. This is about types of friction, that is static friction and rolling friction, kinetic friction and rolling friction. This static friction, sliding friction and rolling friction comes into dynamic friction, as well as that is kinetic friction mostly considered as the sliding friction, and rolling friction which is body is rolling on the surface. At the point of contact the velocity of that area will be 0. This is about types of friction.